Hi, everybody. Thank you for coming. Appreciate you being here. Happy Thursday. So my reminders are the homework 1 is due in 1.5 weeks. This decreases by a 0.5 every time we meet. So please work on it. Hopefully you're working on making a prototype for the heist behavior. So that's like a minimal working example. And from there, you can build and make it bigger. So the idea with software projects is to don't like, I'm gonna say this and don't take it out of context. Like if you dream big and then try and implement that dream right away, chances are you're gonna fail because it's not gonna work. Because that's just how software works, right? Like if you try and build something that's super outrageous, then chances are you're going to get a bunch of errors and then feel discouraged and go take a nap or something. But to build an actual, like, have a sustainable workflow, start small. And then once you have something small that works, then build your way up. So create a minimal prototype for the heist. Hopefully you are implementing the class for binary array. So if you've got the constructor, that's like the hardest part. And then the class for that is fairly straightforward. And then hopefully you're also working on a plan for the binary array driver. Show of hands, who is done with the script? Seeing a lot of hands over there. That's great. Who has like a prototype or they're working on a prototype for the heist? Okay. Who's done the binary array constructor? No one's done the binary array constructor. Anyone worked on any part of binary array? Okay, please start and work on binary array. That's problem 2 of the homework. So yeah, it's a lot more straightforward. The heist is a lot more creative. Binary array is more straightforward. So please spend some time this weekend and work on both of these problems. The lab 5 is probably due Tuesday. We'll have time in class to work on it, hopefully today and maybe Tuesday, depending on how it goes. Okay, so we'll continue to spend some time now to work on the quote unquote homework 2. Can I try and I want to try and figure out how far along are you? Who's done the, I don't know, wait, how do I want to do this? I'll come around and see how you're doing. But the idea is you want to implement like this hierarchy, the account hierarchy, and then have a bank class. The bank class has a list of accounts. So the bank doesn't extend anything, it just is. It's separate, independent. And then if you can also work on a bank demo, where is it? There's a picture here in the assignment that said you can just hard code all of this data. You don't need to get anything from the scanner or anything. Just say like, make these individual accounts, and then the bank should have a method to add interest. So bank also has a method to add interest that adds interest to all the accounts that can support that. So the idea is that like Tom Baker here does not have an interest checking account. And so when we go to add interest, then Tom Baker's balance does not change. But the other guys, their balance does change. Okay, sounds good. I'll give 20, 30 minutes for us to work on it in class, and I'll walk around and see the status. Okay, so we'll come back here. Okay, so yeah, so the point of that was not only practice in like having this hierarchy that I tell you to create, but also making a new project. And because the code that I've given you so far, I give you code and then you implement it. But what you haven't had so far so much is creating things from scratch yourself, which is an important thing to be able to do. So that's the other purpose of homework too. So I would like to talk a little bit about genericity. This is a complicated topic. It's difficult for me, it's difficult to understand, but we can do it together. So we're going to talk about genericity, about parameterization, and then we're going to work on lab 5. So we'll probably spend just a little bit talking about it, hopefully. I'll give you enough to get going, and then we will go from there. Okay, so I'm unmuted, we're recording, screen is unpaused. Should be okay. Okay, so we've seen examples of different reference types so far. We've created a lot of them. Like you just created an account type, an interest checking account, a platinum checking account, a bank. Those are all reference types, right? They're a type of something that is other than primitives. So something beyond the primitive types that we have started off with Java with. So the motivating example for this one is binary array, which maybe you have not been working on, but hopefully you will work on. So binary array is a class that stores an array. It's a field, and the array is full of Booleans, right? True, false, all the way through. So binary array stores an array of Boolean variables. Let's say we want to have a class that can store any kind of reference variable. So instead of a class that stores an array of Booleans, we want a class that stores an array or a list of any kind of variable. We don't want to put any pressure on it. It could be a house, it could be a combo lock, it could be a shape, it could be an account. We don't want to define this is what's going to be in this array. And we don't yet know how to do that. So we've so far seen like we can have a list of something where that something is a type. So like we can have a list of accounts. But we have to like specify that. And so we want to take it and we want to abstract it a level to say, we don't know what kind of thing is going to be in this list. We want to allow for any kind of thing to be in this list. So one possibility is to use object. So in a lot of places, you'll see the just object. So we've seen it in, I think it was, I'm gonna get this wrong. I think combo lock. Where did I put that? Nope. Maybe seminar. Yeah. So we saw it a little bit in seminar where we take in some object and we're not sure if this object is of type seminar. And so object lets us kind of take a step back and say, I've been given something and I have to check first whether it is actually a seminar object. But object is a way to abstract that and say, I don't know what type this thing is, so I'm just going to call it object. So that's one possibility that we can use. We can say that this is a list of objects. That's a possibility. But the more common way that you're going to see if you get an internship and you go somewhere that uses Java, you're going to see it being used with the letter T or some other letter. So not object, not capital O, object, but T. And so, first of all, why do we bother doing this? Using generic types is useful when we don't know what kind of object we're going to get. And so let's show an example where we're going to have a very simple class that contains some object. So like all the way back at the beginning, we looked at, where was it? It was called intcell. Right? Do you remember this? Where we have a class that stores an integer, and then we've got two methods to read and write the integer. Like very bare bones, store something, and then a getter and setter. So let's do this, but with just, instead of specifying that, hey, this is going to be an integer, we want to allow for any sort of thing that could be contained in this class. So I will create a new folder. I'll call it Genericity. And in that, I'm going to make a new file. And what am I going to call this? I'll call this memory cell. .java. There's an ant on this desk. Okay. So first I'm going to show you a memory cell that uses the object type. So something to know about Java, when Java was created, we've got all this hierarchy stuff, right? Every class in Java that we make has an implicit superclass of object. So in our, like, let's say bank and account, and in our whole hierarchy, there's an implicit superclass that's been here this whole time, but we don't really talk about it. And that superclass is object. And so that's where we get the override for toString. We get the override for equals and hash code and all that stuff. Those things were originally defined in object. And I think it's java.lang.object. So that's where that comes from. And so that's what allows us to use this more general reference type to refer to all of these other types. So it's type compatible because at the end of the day, every class, it inherits object. So this is like the secret, like ancestor of all of the classes. Okay, so we're going to do this and we're going to say, it's just the same structure as intcell, right? We're going to have an item of type object because we don't know what type we're going to get. And from there, we can just have getters and setters where we get the item and then we set the item. And we are referencing it with this generic object keyword. So that's one way to do it. And it works. And this was the standard in Java for a while until more sophisticated generics showed up. So that works, but we're going to look at using it with T. And so T, we put in angle brackets to say that this is a generic type. T allows for any reference variable to be used, so we can stick anything in there, even if we don't know what it is. So we could design something now, and then later on, like months, days, months, years down the line, we can say, we can define a new type, and then stick it into something that's been parameterized with T, and it'll work. So even if we don't know what the type that we're going to use this with now, we could come up with it later and put it in here. When we're using a generic type, the class is, we call it parameterized. So if we've got, when we use the T, we put it in angle brackets, like the less than and greater than, and that goes directly after the class name. So we're going to make a memory cell or a generic memory cell, and we're going to put angle brackets right after it. So we'll look at that in a bit. So for now, I'm going to make a new file. I'm going to call it generic memory cell. And this one, I'm going to parameterize. I'm going to say, this class will store some type, and I'm going to call that type T. And so from here, I can use, instead where I would have used object before, I'll just use T. So I can say private T item, and then I can do getters and setters. And now I can use T instead of object. And so this is the more common method. You can see this when you're using like a list, an array list. So like when you're creating a list of accounts, you are using these angle brackets because array list has been parameterized to say it's going to accept any element, and you just have to say, here's the kind of element that goes in the angle brackets. So like, yeah, we'll see an example for that as well. So, and yeah, so the thing that when it's defined, when Java wrote the list and array list code, they parameterized it with T or E. And then when we use it, we say, here's the thing that's going to go in the list. Okay, so we can make classes generic. We can interfaces. So like an interface, this is something that is part of the language. So comparable is an interface, and it's generic. And so you know that because we have the angle bracket T after the name. You can also make methods generic. The T will go before the return type. Okay, so let's look. We'll look at an example. We can have multiple generic types, as many as we need. So for example, if you're making a map, you can make a map with a key and a value, and you just separate it by commas. These are some common names that people use to for the generic types. So like E stands for element, K stands for key, V stands for value. If you want to hold a number, then it's generally a capital N. And then the common one we'll use is type, so T for type. Okay, so let's look at an example. So we want to make so like the binary array, we want to make a class that has a list of something. So a list of whatever type the user chooses to give us. Let me pull up my code here. Okay, so I'm going to make a class, and this is going to be, I don't know, generic collection.java. And I'm going to say that the things in this collection are of type T. So I'm going to parameterize this class with the angle brackets following the class name. And in this class, I'm going to have a list that contains things of type T. You can name it the list. And I think I have to, nope, doesn't like that. There we go. Okay. So if I import list, then I can have my list here. And then I'm going to have other things. So let's say I want to store the first element and the last element also as fields. We'll see what this looks like when we get there. So for my constructor, I don't need class there. For my constructor, I want to take in an array of things and just put them into my list. And then the core method that I want to be able to do with this class is to describe the things in my list. So I've got a constructor, and then the other method is I want to be able to describe, here's what's in my list. Okay, so let's say okay, so let's think of the things I could describe about the list. I could say that I could say like here's the type of things that are in my list. I could say what other things could I want to say about the list? How long it is, yeah. So like the size. And maybe the first and last element. Let's see, what do I have? And then maybe I want to have, so if I know some sort of things that my list could have, like if I had a list of shapes, maybe I would want to print, here's the perimeter of my shapes. If I have a list of, I don't know, accounts, maybe I could print the total number of assets that each for my whole, yeah, for my whole list of accounts. So I want to be able to print something specific if it's going to be, if it's an account, I want to print the assets. If it's shapes, I want to print the, like the total perimeter or maybe the total area. If it's combo locks, maybe I want to lock all the locks in my list. Do you see what I mean? Where I'm trying to not only print, here's the sort of things in my list, but also print some additional information based on what kind of objects I've been given. So I want to print some additional info and more than just like type size. Okay, so I'm going to use the Java arrays. It's not showing up for me. So I will import Java util arrays. Let's also say so if I want to print the type of things in the list, I have to store the class of them. And so I'll store that in a variable, which I call type. And so I can set that up in my constructor by saying, so first I want to check if the array is not, if the array is null, then I don't want to do any of this. So as long as the array is not null, then I would like to say the type is, I don't know, maybe just choose the first object and say get class. Get class is a method belonging to object, which gets inherited through the hierarchy. So I know that when I've got reference types, it's going to know what to do with get class. So I can save the type of the first thing in the array. I can save the first actual element and the last element. Okay. So now for describe, we're going to do something a little bit different. I'm going to use something called a string builder, which we can use in Java to like add on to a string in separate commands. So I'm going to say string builder equals new string builder. This should import automatically from, it doesn't, it might not import, but it should be, if you get errors on this, let me know. You got errors? No? Okay, cool. Okay, and so from here we can say, to add on a string, we can say the string builder dot append, and we can give it a new string to add on. So let's append a string and we call it, here's our collection. For string builders, we need to add the new line if we want to have a line break. So we need to do that manually in this case. So let's append, and then let's do string.format. And we're going to give it, here's the type. And so we'll give it, so remember the first thing in dot format, that's the actual string. The %s, that's the thing that we're gonna stick whatever comes at the commas into that position. So the type gets put in here as a string. So %s, S stands for string. So this will add the type in there. Let's do the size first and last. So we'll say string dot format, and we'll say the size of the list is, and that will be an integer, which we do with %d. And that goes to the list dot size. And then I'm going to copy these lines because I'm just going to fill it in with different information. So we're going to have the first element, and I'm going to say that's a string, so %s for string. And the first element I save as a field, so I can just say first. Then I'm going to copy this line, paste it, and then change first to last. Because that's also a field. So we're doing okay so far, right? We've got our generic collection. What we got to do at the end of this method is we have to return string builder. And then when we do that, we say string builder dot toString. Because string builder is not a string object, it's a string builder object. And so when we say string builder dot toString, that converts it so that we end up returning something of type string. Okay. Good so far? All right, let's have a quick main method to test this out. So let's say I'm gonna have a list of shapes, and I'm just gonna define, like, I'll have a new circle with radius 3, a new unit circle, which is just radius 1, rectangle, let's say 2 and 3, and that will probably be good. So I'm gonna get, cannot convert from circle to shape. Well, it should be able to. Maybe because it doesn't know where shape is. There we go. Okay, so I had to import shape. And so that, if we import shapes.shape, that way it knows here's where shape is defined. So wherever you've stored your shapes, you should import that. So now I have my list of shapes, and I would like to say, first I have to say, so I create this by saying the type of this type is generic collection, and I'm going to give you shapes into this class, and then you say new generic collection. These ones you can leave empty, you do need the two angle brackets, but you can leave them empty because it can infer it a lot of the time. If you want to be really strict and make sure, you can put shape here, but you don't have to. And then we defined our constructor to say it takes in some array, which we've defined here is S. And so I just want to print shapes dot describe. And so that will call the describe method that I just made. And so I can tell you what it's going to say. It's going to say collection. Here's the type of things in this collection. Here's how big it is. Here's the first thing. Here's the last thing. And so we've got 3 things. So the size will be 3. The first thing will be a circle type 3. And then the other thing will be a rectangle. I'm just realizing now this may not work because I don't think we had 2 string in our shapes. Let's see. Yeah, no, okay, so it did something. So it says, here's the type. It's a circle. The size is 3, which we expected. The first element is a circle. The last element is a rectangle. And it doesn't print anything interesting here because we never defined 2 string in our shapes. Okay. So are we all good on that so far? I know this is confusing, but it's important, I promise. So let's say we want to print, we want to add this total perimeter method for when we are doing describe. So the thing about this is the method should only work for shapes, right? We don't want to accidentally find the total perimeter of a combo lock or of an account. It doesn't make sense. So we shouldn't allow that to happen. So it should only work for shapes. The way we're going to get there is we're going to use wildcards. And wildcards help us to restrict generic types to be in a certain hierarchy. So we're going to say, whatever this type is, it should at least extend shape. So when I'm trying to use this method, the things I'm in my list should be shapes. And so we use that within the angle brackets, we say question mark extends shapes. Yeah, and so that lets us do things that are hierarchy specific. So let's add a method here. And so I'll have a static method that returns a double called total perimeter. And it's going to take in a list of something. And in those angle brackets, I want to say question mark extends shape. And so that says that I'm taking in a list of something, but that something should at least be a shape, right? So I'm restricting the genericity of this list to say, if I'm calling this method, the things that should be in my list are shapes. So we're gonna have, let's say, so once we're here, we're assuming we have shapes. So I'm gonna say, now we're actually gonna calculate like what's the total perimeter. So we'll have a total value and we start that at 0. And then we say for each shape in the array, add its perimeter to the total value. So total plus equals s dot perimeter. And then finally, we return the total. So simple method, right? Assuming that we've got a list of shapes, we're going to iterate through the list and find the total perimeter. We're going to add up all the perimeters for the shapes and then just return that total. So the method itself is fairly simple, but how we use it is what we're looking at. So now back in our describe method, we're going to say, we want to say if the things we're working with are shapes, if we're working with shapes, then we want to call total perimeter. And so the way we're going to say is, there's probably multiple ways to get there. This is the way that I have in my notes, is if, let's just go with the first element, is an instance of shape, then we can say string builder append, and we'll say string dot format. Question?
Yes, I'm confused with the genericity thing. Is the point to create like generic methods that can be called with different object types?
Yes.
So, but then do you catch all those exceptions and all those different scenarios just by hard coding it in?
Yeah, so for us, we're kind of hard coding of if our list has shapes, then I'm going to print this information. So we're hard coding that.
So we know like what the potential use cases for describe are, and we code a different name for it.
So currently the use cases are pretty limited to say only here's the type of the first thing in the list. Here's the size, here's the first and last element. I think we're assuming for this instance that when a new type is defined that we want to describe the list, we would edit this code to say, like, if we're working with some new type, then print some relevant information.
Is print a generic method?
Is
sense?
print a generic method? No. So system.out.println, that takes a string.
Okay.
And so sometimes you'll run into the issue where if you give it an object, it may not work. And it's like, hey, you should give me a string. And so usually you'll have to say like .toString to override it sometimes. So yeah, so print is not a generic method. But other things we've worked with, like lists, they're parameterized. Because like we can make a list that contains anything. Like that's what we're doing here. And we're saying, okay, list, store whatever I give you. Cool. Okay, so for here, we're going to say total perimeter, and this is going to be a double, which we say with %f for floating point number. And we give it total perimeter. And here's where we have to do some casting. So remember, Java limits implicit typecasting. So if we just give it the list, then it's going to be mad at us. Because it says the method total perimeter is not applicable for the arguments. So we've given it a list of type T, even though because we have this if first instance of shape, even though we've got this code, it limits the implicit typecasting. So it's like I'm not sure that the thing you're giving me is actually a list of shapes. So we have to cast it and say, yes, for sure, I have checked. This is a list of shapes. So here, let me put this on a new line. And so we need parentheses before the list variable. And we need to say, this is a list of shapes. I'm sure about this. It's still going to give you a warning. The type, what's it say? The type safety unchecked cast. We did cast it. So it's just being extra cautious. But we're saying here, like, yes, for sure, I can call total perimeter because I have checked that these things are shapes. Okay, so when we run this, we should print the total perimeter. So I don't know, I can't do this math in my head, but we've got 9 pi plus pi plus 2 times 3 is 6. So should give us some decimal number, which there we go. And so now it prints the total perimeter for my list of shapes. And in fact, if I have a list of something other than shapes, then it won't print total perimeter because the things in the list wouldn't be shapes. Okay, all that to say, it gives us an opportunity to restrict things in the classes that we design. So we'll transition into lab 5. And so in lab 5, you're given some classes. So there we go. Okay, so in lab 5, you're given a bunch of classes. So we're modeling a course. So a course is going to have a department, it's going to have a roster. And the roster is comprised of sections. So let's actually draw a picture. So this is like if you're in a super big class and you've got different sections. So like if you've got graduate students in your class, there's like undergrads and then there's grads. And those belong to different sections because graduate students get a different amount of, like, they get different type of credit for the course. And so you've got a course has a roster, and roster has sections. So yeah, so you've got a list of sections. And a section in turn is going to have a list of students. So a section has a list of students, and ideally the student should be the same type, right? So currently in lab 5, there's no, it's all kind of, it doesn't have any restrictions, and your job is to add these restrictions. So in the beginning, you can have, let's see, course demo. So we have a course CS 222. We've got some undergraduate students. We've got some graduate students. We also have some droids. So we're going with the whole Star Wars theme. And so the idea is we can add sections full of students, and we want to make it so that each section has only one kind of student. And we want to make sure, so that's the first step. We want to make sure that like a droid isn't allowed to be in a section or a course. Like we want to restrict it only to students. And so we do have a student type.
Could you explain how to word it?
Yeah, so droid is like have you seen Star Wars?
Yeah.
Okay. So we've got students and we've got droids. So a droid has a designation and a type. A student has an ID with first name and last
This
name.
is like creative decision making in the lab.
Correct.
Not like a real one.
Correct. Yeah, so a student has a first name and last name. We've got undergraduate and graduate. Undergraduate is a kind of student. Graduate is also a kind of student. And so your job is to go into section and you're gonna add something here. You may also add something here to, restrict it to say only students, no droids allowed. And so you'll probably add something here, maybe here. And you'll also want to, so throughout here, there's also like the older type of genericity where we've got object. You'll want to change that as well. So based on something, if you give it like type T here, you're going to want to change object to T and so on. Okay, so we'll have the rest of class and probably maybe the whole time Tuesday as well. We'll see how it goes. But I would like you to be working on Lab 5 and ask questions so we can get this done. And that way you don't have to work on Lab 5 outside of class. Sounds good?
Good.
Okay, let's get going. And so it should be on Lab 5. Should be on GitHub. If there's any issues, let me know.